I'm going to show you how to use the Excel Companion Significance Testing Workbook to generate confidence intervals for the difference between two sample means. I'm assuming you already understand a few essential concepts. I'm assuming that you know how to make mean comparisons with interval level data and that you understand the foundations of inferential statistics, especially the concept of confidence intervals. This video is for people who already know what confidence intervals are and now just want to learn how to generate them with an Excel worksheet. It's easy to generate confidence intervals for the difference between two sample means with the Excel Companion Significance Testing Workbook. You can download this workbook from the Excel Companion's website. You just input a few values specific to the problem you're trying to solve. The worksheet does the calculations and shows you the results. To generate a confidence interval for the difference between sample means, you input 5 values into the worksheet. 1, the confidence level. 2, the sample means. 3, the sample sizes. 4, your assumption about standard deviation. And 5, the standard deviation. These values should be given in the problem you're trying to solve. After you enter this information, the worksheet shows you the confidence interval on a graph, reports its lower and upper bounds, gives you the margin of error, and shows you how it calculated all of these values. To see how it's done, let's work through a couple of examples. All right, the first example of confidence interval for the difference of sample means. The problem reads, a researcher uses an experiment to study the effectiveness of a new method of studying. 389 subjects in the control group had a mean score of 73.8 on a test. 374 subjects in the treatment group had a mean score of 79.0 on the test. The test is known to have a standard deviation of 8.3. Generate a 95% confidence interval for the difference between treatment and control group mean test scores. So looking at the significance testing workbook, this is a difference of two sample mean problem. So I will click over to that worksheet. So let's fill in the worksheet inputs here. It starts with the confidence level. It's at 95, which is the problem I asked for, so I will leave that the way it is. Now we've got sample 1 and sample 2. The difference is going to be calculated, you can see down here in the details, as mean 1 minus mean 2. So this problem is asking for the confidence interval, the difference between treatment and control groups, so a confidence interval for the treatment effect of this new studying method. So that means for sample 1, I want to make this the treatment group. So I'll subtract the treatment group score, take the treatment mean score and subtract the control group mean score to get the effect of the treatment. So sample 1, the treatment group, has a mean score of 73.8 on the test, and there are 374 subjects in the treatment group. In the control group had a mean score of 73.8, and there are 389 subjects. Now look, I got this. Looks like I got this wrong. So in the treatment group, let me read this again. 374 subjects in the treatment group had a mean score of 79. Okay, it says 79 is their score, and there were 374 subjects in the treatment group. In the control group, 73.8, sample size of 389. Just make sure I had those numbers right. Are the population standard deviations known? It's rarely known, but here's the exception to the general rule. I'm going to click yes, because the problem says the test is known to have a standard deviation of 8.3. So the population standard deviation in sample group 1 is 8.3, as the problem tells me that, and in the control group it's the same, 8.3. Okay, now I've entered all the necessary information and I'm getting my results. The confidence interval of the difference of the mean. The difference between the two groups scores is 5.2. The treatment group is 5.2 points higher on the test than the control group is. The lower bound of the estimate is 4.1 .022, and the upper bound of the estimate is 6.378. So if I report this 95% confidence interval, I would say the lower bound is 4.022 and the upper bound is 6.378. Okay, another example here. Example 2, this one's going to feature unknown standard deviations. It reads, the 2005 UK Time Use Survey reported how much time people spend cooking per day. As a table here of the results, reporting the gender, sample size, mean, and standard deviation. Men had a sample size of 1,219, mean 23, standard deviation 32, and women had a sample size 733, mean 37, and standard deviation 16. It asks us to generate a 95% confidence interval for the difference of means between women and men. Okay, so I'm looking at our confidence interval of the difference of two sample means worksheet. This problem asks us for a 95% confidence interval, so I will leave the confidence level as 95%. So sample 1 and sample 2, we've got to input the mean, sample size, and standard deviation for both samples. Now the problem asks for the difference of means between women and men. So I will make women sample group 1 and men sample group 2. So the mean should be a positive number. The amount in minutes more women spend cooking on average than men do. So sample group 1, the women, the mean minutes is 37. The sample size 733. Let me just enter for men, if you have a mean of 23 and a sample size of 1,219. This time the population standard deviations are not known, so I will unclick yes. This sample standard deviation in group 1, the women, reported in the problem 32. Remember, this 32 then is estimated from the sample. It's not known in the population. We're relying on the sample standard deviation as an estimate of the population standard deviation. Now, among men, the problem tells us that the standard deviation is 32. I got this backwards. Okay, so for men, the sample standard deviation is 32. For women, the sample standard deviation is 16. Okay, now let's take a look at the confidence interval results. The point estimate is 14. Women spend on average 14 more minutes a day cooking than men do, according to the survey. The lower bound of the estimate is 11.861 minutes, and the upper bound of the estimate is 16.139 minutes. So if I were to report this confidence level, I would say the lower bound is 11.861 and the upper bound is 16.139. Just so you're aware of what's happening here, when I unclick a population standard deviations known, that was clicked yes in the example 1 problem, but this example 2 problem is relying on sample standard deviations as estimates of the standard deviations in the population. What happens is it switches to, with unknown standard deviations, it's using a t-distribution for inferences about the estimate, whereas in the first example with known population standard deviations, it uses a standard normal distribution. The t-distribution is I guess you would say more conservative because it gives a wider confidence interval than the standard normal does, and does that to account for the estimate of sample standard deviation. I would encourage you on your own to play around with that a little bit and look at, I'm not going to go over it now, but on your own, look at the internal calculations. I included it on the worksheet so you could kind of see how all this is being done, how these values are being calculated. Those are the formulas you see kind of in light gray next to the cells. But I put them there so you can see how it's done. It's not entirely magic, maybe a little magical to you, but it's showing you where the numbers come from. They're not just pulled out of thin air. But the work is being done for us, and so worksheet helpfully tells us what the 95% confidence interval of the difference of means is in this case.